Hello, my name is Urjuan Matrafi, and I'm excited to present my project, MindSync, your personal well-being companion. As we all know, stress is something we all face in our studies, work, and daily lives, and it can have serious mental health effects if not managed properly. Packed schedules, back-to-back meetings, and also digital overload make it even worse. So my project MindSync uses AI to predict stress level from your calendar calendar event, and it will provide personalized well-being suggestions without the need for wearable device. So let's get started. Chronic stress impacts both mental and physical health. Also, modern work and study environments often involve busy schedules and minimal breaks, which increase cognitive load. And most exist tools are one size fit all and lack personalization. So, my project addresses this gap by analyzing calendar event details such as duration, location, and time of the day to predict stress level and suggest well-being activities. So the objectives of this project were, first of all, predict the stress level for each calendar event, aggregate the result into a daily total, also provide personalized suggestion based on daily score, and finally operate in both live Google Calendar API mode and offline fallback mode. Background and related work. Research has shown that calendar data can be valuable for understanding well-being. How Paris and Tateyama demonstrated how event can be linked to mood and stress pattern. Uh, Also, wearable devices can detect stress but are often expensive and raise privacy concerns. So, my project, MindSync, offers a practical alternative, a random forest model combined with a suggestion engine, work in both live and offline mode. The architecture shows three possible input. First of all, live data from the Google Calendar API, also an offline CSV dataset, or JSON fallback file. Data is pre-processed and features are extracted such as meeting duration, location coding, morning flag. For example, if one, it's morning, if zero, it's not, and text vectorization for event summaries. The random forest model predicts the stress level for each event, and predictions are aggregated into a daily score, and suggestions are generated based on that score. The output are available in CSV format or through the interactive Streamlit dashboard. The main components of MindSync are acquisition, live API or offline dataset, also processing, calculating duration, encoding location, morning flag, text vectorization, and scaling. Also, random forest classifier predicts stress levels from 1 to 5. Uh, Aggregation and suggestion, uh, also visualization. This project was developed in Python 3.11 using these libraries, also API. The pipeline is modular with separate scripts for training, prediction, evaluation, and dashboard visualization. Key components: the model um, scalar and text vectorizer are saved for consistent predictions in both live and offline modes. So now I will show you how does this project actually works. First of all, fishing events. We need to go to Google Calendar and create a new event. And here I'm running fetch underscore predict.py to get today's events from Google. And also the system collects details like start and end, times, location, and summary. As you can see, the source is Google Calendar API, one event only. The system calculates duration, encode features, and send it to random first, which will predict the stress level from 1 to 5 for each event. And I'm gonna show you what will happen if there is no event here. I'm gonna run this again. Yeah, here we go. It will directly go to the fallback JSON file and fetch events from there. So let's see the dashboard now. The dashboard is showing three events from the JSON file fallback. The first one, stress level is 3, the second one is 1, the third one is 4. In total, it's 8 for the day. So the total stress for the day is 8, which is high. And here's some suggestion based on the stress level to do between days meetings or in your day. So what will happen if I change this summary for the event? And now the stress level is 3. I'm gonna change it and let's see what will happen. I'm gonna go to the JSON file and here I'm gonna change it to work about. Now I need just to refresh the button here. So now the stress level is 1 because we changed the summary, and the total is 6, which is moderate. And here we have a new suggestion based on the new total stress for the day. So here I added two events for the day. Both have the same summary, which is meeting, the same location, London, um, and also same duration. So the only difference here is one in the morning and the second one in the evening. Let's see the results. I'm gonna refresh this button. You can see that the morning event has a higher predict stress level 3 compared to the evening events, which is 2. This is because our model learned from training data that the morning events, especially long ones, can be more stressful. Our model achieved an accuracy of 80% with macro perception of 0.83, recall of 0.82, and F1 score of 0.82. We observed particularly high recall for stress level 5, meaning the model is very good at identifying high stress events. The balanced class distribution in our datasets helped prevent pace toward a specific stress levels. So most misclassifications occur between adjacent um, stress levels, which is expected given the similarity between them. Class distribution. This shows a balanced distribution of stress levels in the training data. One represents the lowest stress for a single event, and 5 represents the highest. This balance helps the model perform equally well across categories. This chart shows how well the model performs. We can see the stress level 5 has very high recall, meaning the model catches most high stress days. Some mid levels stress, like 3 and 4, are harder to predict uh, with lower scores. Overall, the results show a good balance between catching real stress event and avoiding false alarms. Looking at the confusion matrix, you will notice that for stress level 1, there are no correct predictions. All the actual level 1 events were misclassified as higher stress levels, mostly as level 5. This explains why in the previous slides the perceptions and recall for level 1 were 0, leaving the bars empty. This shows the model struggles with detecting very low stress events, possibly because their features overlap heavily with higher levels in the datasets. Strengths and limitations. Our system is completely non intrusive, no variables, no manual input, and it works both online via the API and offline in fallback mode. It's also interpretable thanks to feature importance analysis. However, it's trained only on synthetic data and currently uses a limited set of features without meeting participant and gap times. Reflection and future work. In the future, I plan to include the average gap between meetings as a predictive feature, test the model on anonymous reward calendar data, and optimize suggestion timing by analyzing historical stress patterns. Thank you for watching.